Okay, here we are in Chapter 5, 5.3, solving radical equations. Now, in this one, we're going to be solving radical equations with one root. First of all, state the restriction on x in 5 plus root 2x minus 1 is equal to 12 if the radical is a real number. First of all, the part underneath the square root sign, 2x minus 1, that's the part that has to be greater than or equal to 0. We've got to focus on that. What it means is that we have to solve for what x is. Add 1 to both sides, divide both sides by 2, and we get the equation x has to be greater than or equal to 1/2 or 0.5. That's our restriction. Now we're asked to solve this equation. First thing we're going to do is we're going to take 5 away from both sides. That is going to leave us with root 2x minus 1 is equal to 7. Why did we do this? Well, the first thing we have to do is get the root 2x minus 1 all by itself on one side of the equation. Then we can square both sides of our equation, and that'll allow us to get rid of the root sign. Root 2x minus 1 squared is just 2x minus 1. And the other side is 7 squared, which is 49. Now we've got a nice simple equation. Add 1 to both sides. Divide both sides by 2, and x is equal to 25. Now we can verify this by plugging the value back into the original equation and make sure it works. And you're going to get 5 plus 2 times 25 minus 1 equals 12. And if we simplify underneath the root sign, 2 times 25 is 50, minus 1 is root 49, and 5 plus 7 equals 12. 12 is equal to 12, we verified it. In example 2, what are the restrictions on x if the equation x minus 5 minus x square root equals negative 7? Solve the equation. If we look at the 5 minus x is greater than or equal to 0, you can add x to both sides of that equation. And if you read it backwards, it says x is less than or equal to 5. Now, it's something you do all the time. If we would have said 2 is less than 3, or you can read it backwards and you can say 3 is greater than 2. So you'd rewrite it the other way. So it's something that we've all seen before. Now, another thing that we need to review is that if you're giving something like negative 2x is less than 6, and we divide both sides of our inequality by a negative sign, we have to change the direction of our arrow. So if we divide both sides by negative 2, we have to change a less than to a greater than. That's why we get x is greater than negative 3. Just something to keep in mind as we move forward on this and you're doing your homework later. Now, to solve this equation, x minus 5 minus x underneath the root sign minus 7. First of all, I'm going to move things around to get the 5 minus x by itself. I'm going to add 7 to both sides, and I'm going to add root 5 minus x to both sides, and now it's going to look like this. X plus 7 is equal to the root of 5 minus x. I rearrange the equation by adding 7 to both sides, by adding root 5 minus x to both sides. Now I can go ahead and square both sides of the equation. When I do that, the 5 minus x underneath the root sign squared, that all is going to disappear to leave me with 5 minus x. On the other side, I have x plus 7, and I have to remember I have to FOIL that. So you're going to get x squared plus, to simplify it, 14x plus 49 is equal to 5 minus x. Now I see the makings of a quadratic equation. So I'm going to bring everything over to one side and make it equal to 0. Add x to both sides. You're going to get x squared plus 15x plus 49 is equal to 5. Now I can go ahead and subtract 5 from both sides, and I get x squared plus 15x plus 44 equals 0. Now how do I solve a quadratic equation? Well, the first easiest way is, can I factor it? If I can't factor it, then I'm going to pull out my quadratic equation, negative b plus or minus the square root of b squared minus 4ac divided by 2a, and plug my values in and figure out what I'm going to get for a solution that way. But when I look at this, I can use the sum product method, because I can find two numbers that multiply together to give me 44 and add up to my middle term of 15. And those are going to be 11 and 4. X plus 11 is equal to, times x plus 4 is equal to 0, means that I have two solutions, one of which is going to be x equals negative 11 and x equals negative 4. However, these are only potential solutions. Because I squared my original equation, I might have created a situation where one of these answers won't work. So we need to verify it. If we take x equals negative 11 and we plugged it into our original equation, you're going to get negative 11 minus 5 minus negative 11, which is 5 plus 11, equals negative 7. So it's get negative 11 minus root 16, which is 4, equals negative 4. And that works out to be negative 15 is equal to negative 4. Obviously, that doesn't work. Let's check negative 4. If I plug in negative 4, I'll get negative 4 minus 5 minus x, which is 5 plus 4 equals negative 7. So it'll be negative 4 minus root 9, which is 3 minus negative 7. And I get negative 7 is equal to negative 7. So that one works. Therefore, I can take the negative 11 and throw it away. That is called an extraneous root. It doesn't work. It doesn't work in our original equation. X equals negative 4 is our only solution.